abstract portion, to talk about solutions to differential equations. And so I think in joining together is great because we provide that language. If you're a math major, you might not even see the relationship between those two until after you've been to graduate school. I mean, at least you guys can see it really early on, the relationship. That's really nice. So again, I like providing this rich language to talk about solutions to differential equations.
So what exactly is linear algebra?
Which one is abstract?
Linear algebra, that's right. Okay, let me give you the very last sentence any professor at any university will give in standard linear algebra course. The final sentence will be, no matter what dimension your vector space is, it's the same as Rn, n-dimensional space. That is to say, if your space satisfies certain axioms, which we will discuss rather heavily in Math 33. Is that clear?
No.
Oh. It's sort of like your glimpse into abstract algebra. I'm an abstract algebraist. I really like linear algebra. Just treat it as a language for which you can discuss things nicely. And we will. How many of you are planning to take a Math 33 here? Okay. Not many of us. I'm surprised. Unfortunately, we only have one section each semester. So anybody planning on taking this next semester?
Yeah.
Yeah, as a matter of fact, so I always have students take 32 and 33 simultaneously. The prerequisite for 32 and 33 is 31. We recommend 32 for 33, but you don't have to. How many plan on taking this spring? All right. You've got a really nice professor this spring. She's really good. Her name's Miley Bear.
Oh no, I wanted to finish up my serious view.
Oh, I'm sorry.
I'll figure it out.
The problem with that 33 class, I teach it so often, is somebody raises their hand and wants to teach it, I have to give it up. It's just so unfair. Yikes! What happened?
Is it even recommended to take both classes at the same time?
You know, it's just not that bad. You
Well, if we
guys,
want to finish up with you, we kind of have to.
Math 32 is so easy. 32 is the easiest course in the entire sequence, and it's only the last chapter that's anything meaty in terms of
What
mathematics.
about taking physics alongside those classes?
Now, I think that would be a workload,
Yeah.
just in terms of time.
Okay.
Yeah, I think that would be a workload. But 32 and 33 are not difficult. They really aren't. Master tutors, they'll tell you that. Do you guys think we can finish up with one more question? I tried to be application-based today because I really wanted to start talking about sequences. So when I send you guys home today and do the homework, I mean, please understand, the author's going to ask you more cold questions that are just solve this DE. You only have one technique, separable technique. Now, I got to confess, this is a way for me to really cheat as a professor. Because this means I get to sneak in on the next exam all your integration techniques. So I'll ask you to solve some DEs in which you need to know how to integrate those things just like on the last test. So that really is what I'm going to do. Today, I'm getting more practical with setting things up.
Yes.
A culture of bacteria is subjected to a controlled environment in order to test a new growth inhibitor. Empirical data obtained from these tests provides a growth model for this bacteria in this particular environment, suggesting the rate is proportional to the square root of the amount of bacteria present. Holy cow. What does this mean? The rate of growth is proportional to the square root of the amount present, a tiny t. I think that's a beautiful sentence that's going to smoothly allow me to write the differential equation. Here we go. The rate of growth is dp dt. Well, to say it's proportional to something, does that mean it equals a constant times something? Where the something is true, but finishing my sentence. Proportional to. Very nice. Look what I've just done. I've written a differential equation. I solved a differential equation. I'll separate it. Yes, sir.
Please spell the difference between P and POT.
Yeah, I intentionally worded things this way because I want you to recognize this P as being the output of a function in time t. And so I think P does represent the population at time t. Now I know I don't have the function yet, but check this out. If I need to solve this t, you want to get something like this, you guys? Watch. Isn't that what I'm really looking for? And so I typically think of the output of my function as a population at time t. It's just at this point I'll suppress the of t business with the parentheses and refer to that output as just a big P. It's my dependent variable. So everybody, I think we can solve this DE. Let's separate variables and integrate with respect to the respective variables of integration. Life's a piece of cake, isn't it? And I think I've been given some initial value conditions. 80 grams of bacteria is placed in a special environment and grows to 1 in 25 grams in 1 hour. Then let's solve this differential equation. Well, I think I started out with 80 grams. So isn't P of 0 equal to 80? So let me plug 0 in for T, 80 in for P. See what I get? I get 2 root 80 is equal to my constant C. Or shall I say, what am I going to say? Is that going to be an 8? Come on, you guys are going to help me again. Jeez. Root 5. Does anybody agree?
So confused.
Yes, thank you. So plugging that back in, I guess I've got this. 2 root P is equal to my KT plus C. My cos is 8 root 5. Oh, shoot. I don't like it. I still got a K. Shoot, how am I going to deal with that? How can I find K?
Isn't K just a constant of some sort?
It is, but in this application, I've got enough information to find it. But I still have T's and P's.
No, I should use your.
Use 125 in 1 hour.
So P of 1 is equal to 125. That means when I plug 125 in for P, I will simultaneously plug in 1 for T. And check this out, you guys. Look at that. I got one equation, one unknown, namely K. Let's solve for it. Does that give me 10 root 5 equals to K plus 8 root 5, I think? Or K is equal to 2 root 5. I can now finally write my mathematical model. I think 2 root P is equal to my K T plus C. I'm running out of room, you guys. Can I dive in over here? Dividing both sides by 2 gives me this. And I'm fading. That was a brand new pen. And if I divide both sides by 2, do I generate this? Is it 4? Now if I square both sides, or shall I say, P is a function in time T is going to be 5 T plus 4 squared. Looks nice, doesn't it?
Well, oh, okay, I see. Pull out the 5.
So you just throw the P of T, just like decide to introduce the T back in.
Sir, I don't have to. And if you like this better, you can always leave it that way. I kind of like using my P of T notation to remind you, the reader, that P is a function of time T. It's sort of like saying this. They're synonymous, aren't they? But don't you guys sometimes do write differently? Don't we write this? It's not that I'm trying to tell you, the reader, that I'm multiplying by x. I'm just saying, I like to remind you that y is a function of x. Yeah, I'm playing the same silly game there. And if you don't like the way I play it, just ignore me and don't do it.
But you were saying up until then, P represented output?
Yeah, just like it does at the end when I had open parentheses t. I think it's the same idea. guys okay?
This is
Since I got some time left, can I write a DE and just tell me how to deal with it? We won't even finish. I won't even write a second line. Just one line. Unless you want me to. How would you solve that DE? Divide both sides by, you're right, this. Also divide both sides by this. Separate variables. Do you think you'd be able to divide those two variables? No.
one side would have to be.
What does that do, divide minus y squared?
Okay, let's go to the left-hand side. You got a 1 over root y, 1 minus y squared. How do you integrate that?
Trig sub.
You could, or
Just state the answer.
just take the answer as. Just take the answer as.
Hyperbolic.
Inverse. Sine
A sign.
of y.
Oh, just sign. Yeah.
And on the right-hand side of the equal sign, what were you saying, Sean? On the right-hand side, you get polynomial or polynomial, but you're gonna
Long division.
long division or add your funky form of 0, whatever you prefer. And then you will.
Trig sub.
PSD all.
That would work. A lot of work. I'd probably commit to partial fraction decomposition.
Oh, that is well.
So, question.
Yes.
So for an exam, like, would that be an example? Or
Yeah.
would you give us one of these word
Oh, they're both
problems
so
right
wonderful.
I think that one's more wonderful than that one.
Would you ever ask us to just figure out whether it's separable or not?
No, I will not be tricking you like that. Separation of variables is the only technique you and I have for solving PEs, other than being able to just kind of differentiate off the top of your head. Any questions? All right. If not, can I talk about some awkwardness with next week? I have no problem with the first section in the next chapter. It's just that I find so many students, when they first study sequences series, they get them confused. And your author has a section that's an intro. He calls it an overview of what's to come. And he talks about both sequences and series. When I come to class on Monday, I'm going to start a discussion off restricting my attention to sequences. So that when I start talking about series, which could be as soon as, the second half of Monday, we don't get them mixed up. So I have a tendency not to really do what he's doing. He mixes everything up, and then the next section says, okay, let's just talk about sequences. So if you don't mind, I'll suppress the notion of series until I'm done with my discussion of sequences. So reading that overview is really good. But certainly section 8.2 is where the meat is.
So are we even gonna have homework in 8.1, or should we just go straight to 8.2 if we wanna get ahead?
I haven't even decided yet, to be honest. I haven't even looked at it that carefully. I probably will discuss sequences. If I don't go beyond sequences, I will ask questions of both 8.1 and 8.2, but only in 8.1 that pertains to sequences.
So, just for, because I kinda went through
And you should.
most of the last chapter yesterday,
Uh-huh.
and I kinda went through 8.1 yesterday too, but if I was trying to go ahead more, should I just dive straight into 8.2?
I think you should read the part 8.1 that devotes its attention to sequences, and then dive into 8.2.
Okay.
As far as homework is concerned, I don't know. I haven't looked. I always get so nervous when I look.
So regarding what you just said, we should read 8.2?
As well as 8.1, but focus on sequences. So everybody, in section 7.8, let's take a peek at the following. he just loves technology.
We all. She like that.
Can I annoy you by taking some time tonight and writing some more questions?
Yeah.
Just post my homework.
And there will be a take-home quiz.
Yeah, I haven't written it yet, but I'll post it before I leave today.
Can you still give us a couple some scroll questions?
Yes,